The Water for All Partnership is an EU-funded initiative for scientific research and innovation for the water sector. Its goal is to tackle water challenges to face climate change, help to achieve the United Nations Sustainable Development Goals, and boost Europe's competitiveness and growth to achieve a water-smart society. The Pillar D of Water for All, led by Water Europe, intends to demonstrate the efficiency of innovative solutions through the water-oriented living labs. This is a series of interviews to the front-runners of water-oriented living labs that will join forces and collaborate in the next phases of the program. Enjoy the series.
Today is the 27th of November 2023, and I'm Anna-Kaisa Ronkanen from Finnish Environment Institute, and I'm interviewing our Ruukki water-orientated living lab. Welcome, Maarit Liimatainen, and please first introduce yourself.
So I am researcher Maarit Liimatainen from Natural Resources Institute Finland, in short Luke. So I'm a researcher working at Oulu, but we have a research station at Ruukki, which is 60 kilometers south from Oulu.
Thanks. And our first question is that what are the innovative practices, technologies, and methodologies used in your WOL?
So first, I could start by explaining that we have a research platform that we are doing intensive water-related research. It's called NORPEAT, and it comes from words Nordic Experimental Peat Agroecosystem, and it's 26 hectares in size, and it's a cultivated peatland. And actually, the peat depth changes from 15 to 75 centimeters. So in other corner, it's like actual cultivated peatland, but on the other end, it's kind of dropping from the peatland category to MAL and almost to mineral soil. So it kind of allows us to study the environmental effects of this cultivation on peatland. And the innovative practices, what we have there is that in this kind of public discussion, what has been in Finland, the cultivated peatlands have been in under heavy discussion in that sense that the greenhouse gas emissions are really high, and the most effective way to mitigate these emissions is to increase the water table level. And then we have been trying to think in our research platform that how we can mitigate these, and how we can get the water into the platform so that we can increase the water table level. And in our case, then we decided that we want to take advantage of the water that is going on the catchment area, so that anyhow the amount of water that goes through the field, especially in the springtime, is quite massive. And then we were thinking that if we could store that water and we could use it on the platform, then that would be also kind of cost-effective way to do this water management. And then we decided that we build this kind of water storage reservoir. It's almost a hectare in size, and then with that we can collect the water from the catchment area. And then because we have this controlled subsurface drainage, then we were thinking that if we can connect this water storage reservoir into this controlled drainage, then we can have a sub-irrigation system that we can control. So that's the kind of innovative practice that we try in our platform to mitigate these greenhouse gases. I mean that we test or pilot, or I don't know how you want to describe it, but in this kind of bigger scale, that if the farmer would have to do it, then we test in the research station that how it can be done in this kind of using scientific methodologies, and then we also have this system so that like if you think in a farmer's point of view, it's 26 hectares is quite big, but the farmer may have a lot more of the fields, and then you have to think that how much it takes time. So we have been doing cooperation with University of Oulu, and then we have been doing this controlling of the sub-irrigation system so that we could use it in a kind of distant control, so that you don't have to go there and walk in the field, but you could use it like with your mobile phone, for example, to open and close and look if they are open or closed. And that's what we have been also now testing in bigger scale, that how it can be done and how difficult or easy it is to use, and what are all this kind of technical point of views that you should take into account.
Thanks, Marit. It was very nicely represented. You already mentioned some social impact and benefit, but can you shortly mention what are social, economic, and environmental impacts and benefits on the local territory and the community of the world?
So in our case, the one societal thing in our case is that if you think that we are now in the research station, and there is quite many of us doing this kind of water management in this research platform, but the idea is that we try to learn that what does it take, and how time consuming it is, how expensive it is, how you are located in the catchment scale, how big is your field and how big is the catchment area, how big your water storage reservoir needs to be. And in this kind of really kind of, how to say, practical things that if, because at the end we would like to be in the position that we could say to the farmer that this can be done, that it's not too expensive, and you benefit also by doing this. But first we have to be able to do it ourselves. And then we have to be aware that if we are aiming to mitigate the greenhouse gases, then by really intensively monitoring the greenhouse gas emissions, but also the leaching, then we can say that by doing this, you can actually mitigate. And then you can mitigate, and then it costs this. So the idea is that we kind of try to do it so that then we can say to the farmer, for example, that it can be done and it's not too expensive. And one thing in our case also, like if you think the local benefit of the study is that we are located in this acid sulfate soils. So in this kind of fields, it's really important also this water management. So they cannot be too dry, so that there are no negative impacts of this acid sulfate soil. So and also that if you make, for example, this water storage reservoir, and then you have to make quite big digging of the soil and these kind of things. So we have been studying also from that perspective, that when we do the system, what we have, that it cannot have negative impacts on the environment. And maybe like kind of the red line in our study is also like that if you think that the cultivation in northern conditions, because we are quite north, if you think the whole Europe and Oulu, Siikajoki area, and we are really north. And then you can also think our studies that how is the cultivation in this kind of really northern conditions, and the environmental impacts, what comes to greenhouse gases or the leaching, because the study, the aim of the study is also that you cannot mitigate the other but increase the other. So there has to be a balance in that sense also.
Yeah, so find like a sustainable way to do this cultivation on peatlands. So it means that it's like economically a good thing, but also benefit to the nature, to the waters, and to the climate. Okay, our next question is that what lessons have been learned and what challenges have you faced in your role, and how did you overcome them also?
Well, I think the one has been, for like, first of all, then the moment when we wanted to have the water to the field, like the extra water, like that before, like previous 5 years, we were doing the research in that sense that we have the system that is kind of like relying on the water that comes through the rain or like melting snow in the springtime, but we couldn't store it at all. But the moment when we wanted to kind of take the research further by storing the water, then it's immediately a catchment scale thing. So then you have to discuss with all the neighbors and other people who are on the catchment area, and then you have to kind of be sure that like what we do, it's okay for the other people also. And then you have to think that where your field is located, like in our case, there are private landowners on both sides of our research field. And then it's kind of like negotiation with other people. And you have to have that kind of solution that it's okay for everyone. And after when we started to do this water storage reservoir, and then we connected that to this field controlled subsurface drainage, then it was like when you do it in that big scale as we do, so that you have 26 hectares of the field, it's really like you can compare it to the farmers in that sense that like farmers situation that like the first year we had also a system that didn't work. So there was leaching here and there. The water was going somewhere that we didn't understand when it goes. And basically the first year was really like piloting and taking kind of putting the system in and then learning that what are all the things that you have to take into account, that you have a system that works and the water goes where you want that it goes. So that was like the one thing that it never goes like straightforward. I mean, it can, but in our case, it didn't. So that was one thing. And then one has been now that we have been now using the system that works, but then there has been the weather. So in our case, this kind of extreme weather events has been also like what we had this fall was that there was a really heavy rains in the area, and then everywhere was just water and like way too much. And it's kind of like balancing in that sense that if you think the growing season, when we want to store the water, if it's too dry, and then we want to increase the water table level. But in the fall, when it usually rains anyhow, then we have been testing the system that when it's like flooding, that how we can use our system. And it's in that sense has been really kind of, how to say, lesson to be learned in that sense that we have been investing these kind of systems that you can use the controlling of this system like in distant, like with the phone. But then when you have all this kind of electronics in the field, and then all of a sudden they are all under the water, and we have been testing that how much they can take and how big risk there is that the things get broken. And then you have to think that like if at the end you want to move this to the farmer's field, then like it's a different thing when a research station has all the electronics, and then like we pay them like from the projects and these kind of things. But then you have to think from the farmer's point of view that if the things get broken, then they cannot be too expensive, because then farmer has no money to fix them. And at the moment we are testing like in the platform that we have -25 degrees Celsius. At the moment it's quite hard winter at the moment, and we have been testing in that sense that if we have all the equipments in the field and we don't take them out before the winter, like in that sense that if the farmer has 400 hectares, for example, field, how much he or she has time to go here and there, take the system out and put them back in the spring? Or would it be better that all the system are in the field all the time? But first we have to test that, like how can they handle this winter? So that has been one thing that we are kind of demonstrating or piloting at the moment.
Okay, thanks. What is the future vision now in your role? And can you provide some tips and tricks for roles that are currently in the process of establishment?
Well, in our case, we have had a really good conversations with companies, for example, who make these kind of wells or the systems that we have been installing to our field. We have also had a lot of cooperation in different projects with the farmers and landowners, so that we get the direct feedback of the things that we have been implementing and developing, and especially about the money, that what the farmers think that it's reasonable and they think that they benefit, and what is not too expensive, and what they think that what are the things that they can do in their farm work, that because it's pointless to develop something that the farmer then say that it's not useful at all. So then it's really important to have this discussion with the farmers and then the companies, but also the people who are doing this kind of advisory work, so who are actually helping the farmer when they think that, or they start to think and plan that what kind of water management they could do. And then they have these different advisory organizations, for example. So it has been also really important to think these things together with them, that how much they would need help, and do we have the knowledge to offer. That has been also really important. And in the future, then we really want that this is a long-term study. So because the weather changes every year, sometimes you can have a mild winter, sometimes you can have a really dry spring and summertime, and then so that you can say, like in big picture, that is this useful or not, can we mitigate the greenhouse gases or not, then we just need years. And then this technical point of view, that we have been trying to develop a system with University of Oulu that you can use with mobile phone. Then one aim in the future is that if we could have a totally automated system, so that you don't even have to use the phone, that you don't have to make the decision if it's open or closed, but the system would make it. That's kind of the aim that we try. We try to go further with that, but then it's also a matter of these discussions with these different stakeholder groups, that is this useful or not, because that should be the aim, that it's useful whatever we invent.
Yeah, thanks. How about those tips and tricks for walls that are currently in the process of establishment? So can you say something for this kind of cases? How to start, or what are the most important thing?
Well, I think the advantage, at least in our case, has been that it's big enough scale, so that you can really say that if we are able to do it, then the farmer should be able to do it also. So at least that's one thing. And also that you have these different point of views, that then you can look the catchment scale, you can look the field, you can look the greenhouse gases, and you can look the leaching. So then you can kind of really form the overview of the whole thing. And also that when you look at the same time the costs all the time, then you can kind of say at the end that were you able to reach the targets and how expensive that was, and does the farmer think that it's useful? So I think in that sense it's kind of the research in our platform, it's quite, how to say, multidisciplinary. So we try to take these different angles into account so that then we can say that.
You have a very nice communication between farmers and other stakeholders in the area. So do you have any tips for that direction? What is the best way to create this kind of trustness between different players in your world?
Well, I think it's actually quite a lot of work. And like in our case, that we have about 20 farmers that are in cooperation with us, and it has been requiring a lot of phone calls, and I have been going to every single farm one by one, just going to visit them, kind of take a look of what kind of farm they have, what kind of things they have, to kind of build the understanding that you have this kind of thing, and then your motivation or interest is maybe this kind of, and then when you kind of understand better what they do, then it's easier to discuss with them in this kind of bigger scale of, for example, water management. And it has been really it has been easier for us in that sense that we have these farms that we do water management in their own field also, so that then we can compare this our platform, that when we do it in this kind of intensive platform, and we have a huge amount of different sensors and loggers, and like if you think the amount of numbers that we get, and then we go to the farm and they have maybe one water table tube and nothing else. So then we can compare that, like how much information the farm needs, that they are willing to take the risk of water management, for example, that how they can make the decision that now they want to increase the water table level if they don't have that many numbers that we have. And in that sense, the research what we do in the research platform, you can think it also in that sense that how much information you need to have that you can make a decision, like in the farm, so that then you study intensive enough to get the least amount of data that the farmer needs for the decision making. And in that sense, it's really valuable that you have the farms also. And then they say, because for example, if you think this water management, how it has been previously been, that the farmers always think that how to get the water out. But now we think that how to get the water in. So it's totally upside down. So it's something that takes time even for the farmers or other stakeholder groups, that you have to think it now other way around. And then you have to think that we have built something, but then the farmers have existing kind of, for example, drainage systems. And then you have to think that what is the capacity of them, for example. And then you combine the intensive study to the farmers' experiences.
Thank you, Maarit, for this interview.
Thank you.